Okay, we are going to go over these answers for your solutions InfoQuest. And your InfoQuest is what we did a couple days ago. We're using that virtual textbook online. The link is right there on Google Classroom. And so we're going through those things about solutions. So when you went through solutions, you were looking at just the first 4 pages, pages 1 through 4, and these were some of the key terms that were on there. So when we go through these definitions, this is the way that you should have them. A concentration is a description of how much solute, that should be solute, has been dissolved. Usually it's shown as a ratio. So like if you have a lot of solute that is dissolved, then you would have a very highly concentrated solution. So if we think about our sugar solutions that we were making, if I was making those solutions with a lot of sugar, I'd have high concentration of sugar water, and it would be very, very, very sweet. If I was making a diluted solution, which we'll get to later, it would be low concentration, and it would have very, very little sugar, so it would be a little bit sweet. The second thing is concentrated, and that's kind of what we just talked about, a solution that contains a large amount of solute compared to the solvent. So again, if I added a bunch of sugar to it, it would be very concentrated. Just like if I were mixing paint and I add a lot of dye to that paint, if I was making purple paint and I added a lot of purple dye, it would be very concentrated, a really, really deep purple. But if I added a little bit of purple dye, then my paint would be diluted. It wouldn't be very concentrated. So a solution, what we've been dealing with, is a homogeneous mixture. Remember, homogeneous, it has the same parts throughout. It's very evenly mixed. The solute is evenly distributed through the solvent. The solvent is the substance that does the dissolving. A lot of times that's water, because water is called the universal solvent, which we'll get to later. Because it can dissolve many, many things. And over time, you think how water dissolves even rocks, and it will dissolve lots of things. So it's the universal solvent. But a lot of times it's water. It doesn't have to be water, but it is a lot. So the mixture is a combination of 2 or more substances combined physically, where each part will keep its own chemical properties. So we noticed with our sugar water, when we added sugar to the water was still water, still liquid, and the sugar added its sweetness. And it really still had the granular texture. You just really couldn't tell that once it was inside the solution, inside the water. Agitation, we talked about this. This is stirring. Agitation is the same thing as stirring. So when we stirred the liquid, we noticed that it dissolved a little bit faster than it normally would if you stir a solution, agitate it. An aqueous solution is a solution where the solvent is water. A lot of times we have an aqueous solution. You don't have to have water necessarily, but if it is a water as your solvent, you have an aqueous solution. The solute, I always remember the solute as what you are adding. So you add the solute to the solvent. Majority of the time the solvent is going to be a liquid and the solute is going to be a solid, a powder of some sort. So the solute is a substance that's being dissolved, and it disappears after it is dissolved. It doesn't like go away, but you can't see it anymore because it becomes evenly mixed in a solution. Surface area, this is probably the hardest thing when we were talking about the surface area of the sugar. We talked about the amount of the outside part able to be touched by the solvent. So we talked about the sugar cube. The cube looks like this. And then you had the granulated sugar, which looks like this. So we talked about surface area. The water is our solvent. If I drop both of these into the water, you think about the water molecules can only touch what's on the outside of that cube. And if we measured this out and had the same grams in just the crystals that were just kind of granulated, the water can go all in between those crystals. It can touch every single one of those crystals, and it dissolves it a lot more quickly than it does, because on this one it has to dissolve the first layer, and then it has to go away, and then the second layer, and then it has to dissolve that, and then the third layer. And so it doesn't touch those crystals that are locked in the middle of that sugar cube for quite some time. The hotter the water, again, the faster it would do that. But when you look at those two surface areas, so this one, the granulated sugar, has a lot of surface area, okay, because that area that water can get to is a bunch. On this one, the cube, the surface area is less because there's only so many crystals that water can touch. Okay? Same concept goes for surface area, like if I were cooking potatoes and you think about making mashed potatoes or whatever. So if I take those whole potatoes and I throw them in the pot, it takes a lot longer for the whole potato to cook than if I were to chop up those potatoes and then put them in the pot. They would boil and soften a lot more quickly than the whole potato itself. And that has to do with how much surface area the potato touches the water. In that case, or touches the heat, the hot water, because you're conducting heat to cook that. But same thing, same idea. Diluted means that a solution contains a small amount of solute. So again, we talked about concentrated being linked to diluted. So again, if we take our purple paint and we add just a little bit of dye to the paint itself, then you would have a diluted solution. You have a very, very light purple color. If I was making Kool-Aid and maybe only used half of the pack instead of the whole pack, it would be more diluted than a concentrated, than a bunch of Kool-Aid there together. Okay, temperature, this is an old word, average kinetic energy of the particles, right? And so it moves around, so we know if the temperature's higher, the solution, the molecules in the solution are moving faster, temperature's lower, and that's an old word, that goes back to energy. And solubility, the ability of a solute to be dissolved within a solute. So you think about ability, solubility is the ability to be dissolved. All right, let's look at this page right here. So when we look at heterogeneous and homogeneous, this goes on this side and this goes on this side, and the way that they're together in the middle is the way that they're alike. So this is where they are alike. Okay, so when we look at these, they're both mixtures. So there are two or more, I put 2+ substances mixed together, right? So 2 or more substances mixed together. They keep their physical properties, and then they can also be separated by physical means. So that means they can be filtered out, they can be evaporated out, they can be using a magnet to get those out. How else do we separate a mixture? You can boil it and then go through the distillation process. Basically, you boil it, you capture the purities, the impurities stay behind. That's the distillation process. So those are the ways that we can separate some mixtures without a chemical reaction. So mixtures are not chemical changes, they're physical changes. On this side here, let's start with homogeneous. These are the parts that you can't see. They're evenly mixed. Solutions and colloids are things like this. So if I can't see the parts, it's a solution, but it's 2 or more things mixed together. Those are homogeneous mixtures. So things like coffee and tea and sugar water and Kool-Aid and paint. And if you think about maybe like French salad dressing where you don't see the little parts, and those are things that are homogeneously mixed. Heterogeneously mixed is different throughout. So the parts are uneven, so you can see the parts. They're easily seen. They're uneven in suspensions, and that would be like your Italian dressing where you could see the little parts and they'll settle out after a while. So a suspension is a heterogeneous mixture. A salad could be a heterogeneous mixture. A chocolate chip cookie is a heterogeneous mixture. You think about the different parts that are there. And that you can see them. So that's the difference in heterogeneous and homogeneous. That's a big 8th grade concept. And then down here we're going to talk about the types of mixtures. So, we've got heterogeneous and homogeneous, but we've got something called specifically a solution, which we've been dealing with, which is a type of homogeneous mixture. The parts are too small to see, and they won't settle out. A colloid is the same thing. Homogeneous mixture, except their particles are a little bit bigger, and you can't see the particles and they won't settle out. So the difference here is like salt water and Jell-O. Colloids are usually a little thicker. A colloid mixture, you've ever made oobleck? We'll make oobleck in class with cornstarch and water where it's compacted and it becomes a solid and then it's kind of a liquid. Things that are kind of that like Play-Doh and silly putty and pudding and things like that are colloid mixtures, where a solution is a lot more liquidy and the parts are a lot thinner, I guess you could say, and move around, flow a little bit easier, and they won't settle out. So again, sweet tea, lemonade, those types of things. All right, a suspension is a heterogeneous mixture. It's things that are suspended in something else. So your solutes are suspended, but they will settle out over time. It has larger particles. Again, this is your Italian salad dressing is what they used. Is the example in the text. You can see the particles and they'll settle out. All right, let's look at these questions here. What type of mixture is a solution? It's a homogeneous mixture. How particles are distributed within a solution? They are evenly distributed. Can the particles be seen within a solution? No, you can't see the particles. Will the particles settle out? No, they won't settle out. What does uniform mean? Uniform means something's evenly mixed, or it's the same. You think about putting a football team in uniforms because they're all one. They're acting as one thing. They all look the same. So uniform means evenly mixed. Everything's going to look the same. All right, what are the two parts of a solution? You got a solvent and a solute. And the part of the solution that dissolves is a solute, right? So you add the solute. It's usually a powdery substance that you add to the solvent. The part that does the dissolving, your water, is usually the solvent or the liquid that is dissolving into. Doesn't always have to be, but a lot of times it is. All right, if we're making Kool-Aid, our solute is the powder. You could even put sugar in there because you got to sometimes add sugar. Sometimes the sugar's in the mixture. Sometimes you add sugar separate. So it's the powder part, so the sugar and the flavoring, right? That's your solute. You add that to your solvent of water. Salt water, if you're making salt water to maybe swish in your mouth or gargle, you got a sore throat, they tell you to gargle salt water and things. You put salt, that's your solute. You put salt into the water. That's your solvent. Sugar water, same thing we've done in class. Your solute is your sugar. You're adding the sugar to your solvent, which is your water. And why is water called the universal solvent? We talked before, it can dissolve many, many things, including rock over time. Our solutions, usually solids, liquids, or gases, they're usually liquids. Most of the time, our solutions are usually liquids. Don't have to be. How is an alloy considered a solution? An alloy would be solids. And an alloy is actually a mixture of two metals. So that's how it is considered a solution, because you have two or more metals that are mixed together and they're even. So when you mix them together and they're a solid, you usually mix them in the liquid form and then you heat them up to mix them. But then it come back to a solid and you really can't tell. So like if you think about a gold ring, that gold in your jewelry is actually an alloy. It's not pure gold. It's a certain amount of gold mixed with some other metals to make it a little bit stronger. So I can't look in there and see where the gold particles are, and I can't see where the the alloy, the other metals they mixed in, but that is what happens. It's a mixture of two metals. All right, and how is air considered a solution? It's a mixture of gases. And again, it's a mixture of gases and you can't see the parts. Like I can't look at the air and say, oh, there's an oxygen molecule. Oh, there's a nitrogen molecule. Oh, I see this, I see that. Your air is transparent. It's there, but you can't see the parts. And so it's a mixture of gases is what that is. All right, down here, what does concentration measure? It measures how much solute is in a solvent. So if you have a bunch of solute, it becomes concentrated. If not, it becomes a diluted solution. So concentrated solution is a lot of solute. A dilute solution has less solute, and that is compared to if they have the same amount of solvent. So again, a lot of solute compared to what it's dissolved in, and less solute compared to what it's dissolved in, or little solute. So there's our main ideas. On the back side, we're looking here. These are the three factors, and these are the three factors we tested in our lab: temperature, surface area, and agitation. What is temperature? It's the average KE. Remember, KE means kinetic energy of the particles. And so if I increase the temperature of the solvent, I will increase the rate that the solute dissolves. Surface area is the amount of area that the solvent can actually touch We talked about that with the cubes and the granulated sugar. If you increase the amount of surface area in the solute, you will also increase the rate that that solute dissolves. Oh, sorry, surface area of the, yeah, that's right. And then agitation, what is it? And I just put stirring right there. If you agitate a solution, you stir it. If you increase the amount of agitation of the solvent, you will increase the rate that the solute dissolves. So if I stir it more, it should dissolve quicker. And those are kind of basic things. And in this one right here, we're looking at, in your own words, to summarize what you're talking about with your 12 words. So I didn't write it out here, but I'll go over with you kind of what I'm looking for. When I am looking to write, I'm going to look at how my words are connected. That's the very first thing I need to do. So I know that we're talking about basically a solution, and a solution has two parts. Solutions have a solvent and a solute. So my very first sentence, when I look at my main idea, I might want to start with those couple words. Say, you know, a solution is a homogeneous mixture that is made up of two parts, the solute that is dissolved into a solvent. So then I've used those three words, and that's in one sentence. Okay, then I can talk about, see how the next thing, well, oh, I even said mixture, didn't I? So I even used mixture. So a solution is a homogeneous mixture with two parts, solute and solvent. So I've used 4 words in one sentence. Then you could say that solutions can be concentrated or dilute. Okay, so they could be concentrated or dilute, right? So I'm using those two. Solution that is concentrated has a lot of solute. A solution that is not concentrated is considered diluted, so it has less solute. So you could phrase that a little simpler, but those kind of pairs go together. One of the things that you could talk about also in this, you know, you could say that there are 3 things that affect the rate at which a solute dissolves, right? The 3 things are the temperature, the surface area, and the agitation. So those kind of link together, right? And then I also know that, let's see, solubility is the ability to be dissolved. So I could squeeze that in with the solute, talking about what a solute is. Then aqueous solution, I can talk about, that is when your solvent is water. And then you have a concentration, which I could have talked about with the concentrated or not. So let's talk about how we would write this. So I might begin to say a solution is made up of 2 parts, or is a homogeneous mixture made up of 2 parts, a solute and a solvent. All right. And then I could go on to kind of explain the other things. I do not want to just list definitions again because we did that on the front. So you want to be sure that when you summarize, you are kind of linking those things together into a paragraph that explains it more than you're just, you know, listing definitions. So that's what I was looking for there. All right, so now we've gone over this. If you don't have any questions, we're going to move on to the solubility InfoQuest, which is the next pages, and so it's this one. And you can get that from me if you don't already have it, and work on completing that, and we'll go over that after we do some labs and practice.